Students, Sairam, this is Megha Miss here, and today we are going to start with the continuation part of lesson number 14, Substances in Common Use. This is our session 2, students. Now in session 1, if you remember, we studied about the important salts. Okay, we have studied it can be acidic, basic or neutral salts we have studied depending upon the pH. Then we studied about sodium chloride and sodium bicarbonate, its properties and uses. And as I told you, at least 4 points of each you have to remember. Okay, students. So we'll continue with the lesson now. The next part we are going to study, that is bleaching powder, students. Okay. Now that is also we called it as calcium oxychloride, that is CaOCl2. Now the tap water has a typical strong odor in the rainy season. Okay, have you experienced it? Yes, you must have experienced. Okay, water in a swimming pool also has the same odor. It is the odor of the chlorine gas used to destroy the microbes in the water. Okay, students, so that smell or that odor is nothing but the odor of the chlorine gas. Okay. Chlorine gas is a strong oxidizing agent and therefore it has a strong disinfecting as well as bleaching action. Okay, so for all these things, because of this properties of the chlorine gas, okay, we are using it in the water in the swimming pools, also in the tap water during rainy season, as it has the capacity to kill the microbes in the water. Okay, students. Now chlorine is inconvenient to handle because of its gaseous state. Now you cannot handle it easily, students. Okay. Instead, the solid bleaching powder, which has the same effect, is more convenient to use. You must have seen a bleaching powder at your home also, whitish, yellowish color powder it is. Okay, you must be using, mostly it is used to clean the toilets and all, okay, to kill the microbes and all. Okay. So, bleaching powder undergoes slow decomposition due to the carbon dioxide in air. So, bleaching powder, it reacts with the carbon dioxide in the air and chlorine gas is released. Bleaching powder get its property because of this release of the chlorine gas. As bleaching powder also has the capacity to release the chlorine gas, we are using the bleaching powder. Okay, as chlorine is directly using it, it is inconvenient as it is in gaseous state, so it is easier to use this bleaching powder. Okay, students, I hope till this part it is clear. Okay, we'll proceed. CaOCl2 plus CO2 gives you CaCO3 plus Cl2. Okay, you will remember the reaction, students. Bleaching powder is obtained. How you will get bleaching powder? How you will make it? By the reaction of the chlorine gas with the slaked lime. So CaOH twice plus Cl2 gives you CaOCl2 plus H2O. Okay, all these reactions, students, you will write in the book and practice. Okay, important, all the reactions are important. Okay, students, now some properties and uses we will see. Bleaching powder is a yellowish white colored solid substance. Okay, you can see it at your home also if you have. Okay, its chemical name is calcium oxychloride. Okay, so the chemical name is calcium oxychloride. Important to remember. It has a strong odor of a chlorine gas. It is used for the disinfection of drinking water at the water works, means wherever the purification of water and all is taking place, and the water in the swimming pool or industrial areas also, wherever the water is to be needed to for different purposes, there also it is used. It is used for the bleaching of the cloth. Okay, now sixth one, it is used for disinfection by the roadside and garbage sites. Wherever there is a garbage sites and all roadsides, there also it is used. Dilute sulfuric acid and dilute hydrochloric acid react rapidly with bleaching powder to release chlorine gas completely. Okay, CaOCl2 plus H2SO4 gives you CaSO4 plus Cl2 plus H2O. So chlorine gas, as it is a gas, students, you can see it is shown by a arrowhead which is pointing upwards. Okay, so always the gas which is released or in the reaction, whenever the gases are released, it is shown by the upward arrow. Okay, calcium oxychloride reacts slowly with carbon dioxide to form calcium carbonate and chlorine. So we have seen that calcium oxychloride reacts slowly with carbon dioxide gas to form calcium carbonate and chlorine. So you can get the formation of calcium carbonate also. Okay student, all these reactions you are going to write. Please write them and practice. Okay. So we'll proceed. Next one we are going to see, that is washing soda. That is Na2CO3.H2O. The hard water from the well or a bore well becomes soft on adding washing soda, and we come to know this from the lather formed on it. Okay, so hard water from the well. Okay, the well water is a hard water or a bore well. Okay, it will become soft when you add washing soda to it. Okay students, the hardness of the water is due to the presence of the chlorides and sulfates of calcium and magnesium in it. Why it is a hard water students? Because it contains many type of the chlorides and the sulfides, of whom calcium and magnesium. Na2CO3 is added to it to soften such water and make it suitable for the use. So to make it suitable for the use, what we are going to add students? We are going to add washing soda. The reaction with Na2CO3 causes the formation of insoluble carbonate salts of magnesium and calcium. Okay. Now, MgCl2 plus Na2CO3 gives you MgCO3, that is the carbonates are formed, okay, plus 2 NaCl. Sodium carbonate is a water soluble salt of sodium. Crystalline sodium carbonate on keeping loses its water of crystallization readily and a white powder is obtained. This powder is called washing soda. Okay, Na2CO3 plus that is dot 10H2O. So this 10H2O is the water of crystallization. Okay student, so when this 10H2O, if water of crystallization is removed, you get Na2CO3.H2O. Okay, only one single. First it is 10H2O, now only one single H2O. It is a white powder which you called it as the washing soda. Okay students, I hope till here it is clear to you. Okay, reactions practice. Okay, now properties and uses. Washing soda is a whitish and odorless powder at room temperature. It is a odorless powder. Okay students. Litmus has a blue color in its aqueous solution. So in aqueous solution you will see that the litmus gives a blue color. Okay. It is hygroscopic, that is it absorbs moisture if left exposed to air. So if that washing soda, if you keep it open, okay, exposed to air, you will see that it absorbs moisture from the air. Okay, so it is called as hygroscopic. Okay students, then it is used mainly for washing clothes. Sodium carbonate is used in the glass and paper industry and also in refining of petrol. Okay students, so you will remember, we are washing soda we will always use for washing clothes, and we will also sodium carbonate we are using it in the glass and paper industry and also in refining of petrol. Okay, some crystalline salts now we will study. Okay students, you have learnt about water of crystallization in previous chapter. You know what is crystallization water, right? We used various salts which contain water of crystallization. Some substances in our daily use which contain water of crystallization are, so we will see which are those substances which we use, salts which we use in the daily life which contain the water of crystallization. Okay, so see here, first one, alum, we also called it as potash alum, K2SO4 dot Al2 SO4 thrice dot 24H2O. So how many water is there? 24 water molecules are there. Okay, borax, Na2B4O7 dot 10H2O. Epsom salt, that is magnesium sulfate, MgSO4 dot 7H2O. Barium chloride, BaCl2 dot 2H2O. Sodium sulfate, globose salt, Na2SO4 dot 10H2O. So see students, here everywhere you will see that this whatever the water molecules you will see, okay, that is called the water of crystallization. Okay, and yes, if you heat it, this water of crystallization can evaporate, but again if you keep the salt open, it will absorb the moisture and again it will come back to its original state. Okay students, so I hope all these crystalline salts are also clear to you. Okay, should we proceed? Okay, now see here, alum is used in the purpose. Yes, what is the purpose of alum? For the process of water purification. Because of the property of coagulation, the solid impurities in the water come together, become heavy and settle to the bottom. You know, your parents must have used alum. Okay, in Marathi we called it as tulti. Okay, so alum, it is used in the process of water purification because of the property of coagulation, means the particles coming together. Okay, so the solid impurities in the water come together, become heavy and settle to the bottom. As a result, the water above becomes clear and you can drink that water. Okay, blue vitriol is used in the blood test for diagnosis of anemia. Now anemia means, you know, the condition where iron in the body, hemoglobin in the body, iron in the body goes on decreasing. Okay, the levels decreases. So blue vitriol we can use in the blood test for the diagnosis of the anemia. In the Bordeaux mixture, which is used as a fungicide on fruits like grapes, muskmelon, slake lime is used with the blue vitriol. So we can also use the slake lime with the blue vitriol for the making this mixture, okay, which is used as a fungicide on the fruits like grapes and muskmelon. So what we can make? We can make a Bordeaux mixture. Okay students. Now soap. Now the next part we will see about the soap. Now we have seen about washing soda and all. Okay, is there any difference between that washing soda and our soap? Can we use that washing soda for our bathing purpose? No. So when oil or animal fat is boiled with an aqueous solution of sodium or potassium hydroxide, sodium or potassium salts of carboxylic acids, that is fatty acids, are formed. These salts are called as soaps. Okay students, so you will remember the definition type only. Explain what are soaps. When the oil or animal fats, if you are using, and it is boiled with the aqueous solution of sodium or potassium hydroxide, sodium or potassium salts of carboxylic acids, that is the fatty acids, are formed. These salts are called the soap. When soap is mixed with hard water, calcium and magnesium salts of fatty acids are formed. If you know, in the hard water you have calcium and magnesiums, right? Salts are there. So when I am mixing this soap with the hard water, calcium and magnesium salts of fatty acids are formed. Okay students. These being water insoluble, they form a precipitate, and that is why lather is not formed. Okay, they will form precipitate. Okay, at the bottom they will form the precipitate, and hence the lather, you know, the bubbles and all will be not formed. Okay students, so I hope it is clear to you. So soap we cannot use in the hard water. Okay, in short, is it clear students? Okay, so I hope till this part it is clear to you. Okay, so we have come to the end of the today's presentation. So today we studied about bleaching powder. You saw, yes, we are using bleaching powder at home also, and it is like we are using it for the to kill the microbes and all. Okay, chlorine gas is released and hence it will be helping us to kill the microbes. Then we studied about washing soda. Some crystalline salts we saw which contains the water of crystallization. Many examples we have seen. You will write and practice along with their formula. Okay, and then we studied about the soaps. Okay, bathing soaps and the soaps, washing soda and all, they are totally different. Okay student, so I hope whatever we did today you will go through it properly, study it well properly. Okay, so we'll meet in the next presentation and continue with the lesson. Okay, so I'll stop it today for here. Thank you. Sai Ram. Take care.